Hey everyone, welcome back. Ready for another deep dive.
Absolutely. Always up for a deep dive.
Today we're tackling something, well, kind of essential, for breathing.
Let me guess. Oxygen.
You got it. Oxygen. We've got a Wikipedia entry and this really interesting excerpt about its history. Should be fun.
Definitely. Oxygen is more exciting than people realize.
Right. Imagine trying to explain it hundreds of years ago. People had some wild ideas.
Oh, I bet. Before they figured it out, what did they think was going on?
Well, our Wikipedia entry mentions this guy, Philo of Byzantium, way back, like 2nd century BCE. He puts a candle in a bowl, water's at the bottom.
Classic experiment setup. I see where this is going.
Yeah, the flame goes out, obviously. But his conclusion, air turns into fire.
Wow. I mean, hey, got to start somewhere, right?
It's true. And to be fair, he was on to something getting used up in the air. Even Da Vinci, years later, noticed that. Both fire and breathing, something in the air was being consumed.
Makes sense. So how'd they go from there to, actual oxygen?
That's where things got interesting. Cue the era of phlogiston.
Ah, yes, phlogiston. A classic, though not exactly accurate.
So basically, imagine this. Stuff that burns, they thought it had phlogiston inside it, like the essence of fire, just waiting to get out.
And when it burned, phlogiston was released.
Yeah.
Makes a certain kind of sense, in a way.
Except no one ever actually found any phlogiston.
The elusive phlogiston. A good reminder that even the most popular theories can be dead wrong. But hey, gotta admire their creativity. And it got people asking questions right.
Exactly. And asking questions is how you get to the right answers. Eventually. Thankfully, it didn't take that long. Fast forward to the 1700s, and we get a trio of geniuses who crack the oxygen code. Scheele, Priestley, and the famous Lavoisier, although they weren't always on the same page about who deserved the credit.
The drama of scientific discovery. Who gets the naming rights? It's always more complicated than it seems.
You're telling me. So, Scheele, he kind of isolated oxygen first, called it fire air. Makes sense, right?
Totally. But did he publish it? You got to publish to get the credit.
That's where Priestley comes in, does his own experiments, similar idea, publishes first. But get this, he still thought phlogiston was involved. Called it dephlogisticated air.
It's like, so close, yet so far. I can just imagine those lab notes. But then Lavoisier swoops in, Mr. Put It All Together.
Right. Lavoisier, he's the one who not only isolated oxygen, but also said, okay, folks, enough with this phlogiston stuff. And of course, he gave us the name oxygen, although.
Although. There's always an although in science, isn't there?
Okay, so get this. He named it oxygen because he thought it was a key part of all acids.
Really? Now that you mention it, I don't think hydrochloric acid has oxygen in it.
Yeah, turns out not all acids are created equal. Shows even the biggest discoveries get refined over time, which honestly is kind of cool. Science is always evolving.
Yeah, acids. Turns out they're a whole other deep dive. Some of them, they get their acidity from hydrogen ions, not oxygen. But that's a story for another day.
See? Always more to learn. But speaking of oxygen, it's not just floating around in the air, right?
Oh, not even close. It's way more common than people think.
Yeah. Our sources said something like, almost half of the Earth's crust is oxygen.
It's wild, right? We walk around on this giant oxygen-filled rock. It makes you look at dirt a little differently.
Totally. So how did all that oxygen get here? It's not like it just appeared out of thin air.
Well, it kind of did, eventually. The oxygen cycle is how it all works. A Wikipedia article has a decent explanation.
Right, the oxygen cycle. Plants and algae, they're the real MVPs here, right? Photosynthesis, it's like the ultimate life hack. Use sunlight, split some water, boom, oxygen.
Did we get to breathe it? It's a pretty sweet deal. We breathe in oxygen, breathe out carbon dioxide. And the plants, they take that carbon dioxide and make more oxygen. It's this beautiful ancient cycle.
But could we mess that up? Because our sources mention things like deforestation, burning fossil fuels, not great for the oxygen cycle, right?
Yeah, that's the thing about balance, right? It can be thrown off. I mean, Earth's pretty good at self-regulating.
So no risk of running out of breathable air anytime soon.
Probably not. But it's not just about how MUCH oxygen there is. It's the whole system, right? This planet's been around for a long time and things have shifted before. It's just the rate we're changing things now. That's the concerning part.
It's humbling, This invisible thing, we need it to live, and it's tied into everything.
Totally. Speaking of needing it to live, it's not just about breathing either. Oxygen's got some surprising uses.
Oh, right, like in space. You need pure oxygen in spacesuits, don't you?
Exactly. Out there, no atmosphere to worry about messing up. But pure oxygen at the wrong pressure, Not so good either.
So there's a sweet spot even with oxygen.
Always a sweet spot. Spacesuits use pure oxygen, but at a lower pressure than here on Earth. Gives astronauts more mobility. Too much pressure, though. That's a problem.
And then there's scuba diving. That uses oxygen too, right?
Definitely. Although, too much oxygen underwater can be toxic.
Wait, seriously?
Yeah, it's called oxygen toxicity. Too much of a good thing.
Yeah.
Divers have to use special gas mixtures. Keeps them alive. And prevents them from getting oxygen poisoning.
So we need oxygen, but not too much. This is getting complicated.
It's all about balance, like we were saying. But oxygen isn't just for life support either. It's a huge part of a lot of industries. You wouldn't believe how much of it goes into making steel.
For real. I do remember reading that. 55% of industrial oxygen just for steel. Why so much? What does oxygen even do to steel?
It's all about impurities. See, iron ore, it's got carbon in it, other stuff too. Oxygen, it basically rips that stuff out.
So it's like a giant oxygen purifier.
Kind of. Gets rid of the weak links, makes the steel strong.
Yeah.
Otherwise, you wouldn't want to build a bridge out of it, that's for sure.
Makes sense. So steel's the big one, 55%. What about the rest of that industrial oxygen?
Oh, it's everywhere. Plastics, clothes. Even some medicines use oxygen in the process. Water treatment plants, too.
It's like oxygen is the unsung hero of, well, everything. But this whole deep dive, it's made me think, like, our sources said oxygen levels on Earth, they haven't always been the same.
Right. It's gone up, it's gone down. Billions of years. Who knows what's next, right?
Exactly. Any guesses? What does the future hold for oxygen?
Well, we can make some educated guesses. Deforestation.
No.
Good. Burning fossil fuels.
Yeah.
Also not good.
Okay, so maybe not so good. But are we doomed? Is that what you're saying?
No, not doomed. But we got to be smart. It's all about balance, right?
Yeah.
The Earth, it can handle a lot, but we got to do our part. Sustainable practices, that's the key.
Sustainable practices. Got it. Well, I think that's a good place to wrap things up, don't you? We've gone from candles and bowls to the fate of the planet.
And we couldn't have done it without oxygen.
This episode was literally brought to you by Oxygen. To all our listeners, thanks for joining us on this deep dive. And remember, there's always something new to discover. Until next time.